Hi, my name is Faro, and today I'll be discussing about aircraft engines in my podcast. This is an animated computer drawing of one cylinder of the Wright brothers 1903 aircraft engine. The engine consisted of 4 cylinders like the one shown, with each piston connected to a common crankshaft. The crankshaft was connected to 2 counter-rotating propellers which produced the thrust necessary to overcome the drag of the aircraft. This is a label diagram of some of the parts inside the engine. The engine cycle begins with the intake stroke as a piston is pulled towards the crankshaft. The intake valve is open and fuel and air are drawn past the valve and into the combustion chamber and cylinder from the intake manifold located on the top of the combustion chamber. The exhaust valve is closed and electrical contact switch is open. The fuel-air mixture is at relatively low pressure near atmospheric and is colored blue in this figure. At the end of the intake stroke, the piston is located at the far left and begins to move back towards the right. As the piston begins to move to the right, the intake valve closes. With both valves closed, the combination of the cylinder and combustion chamber form a completely closed vessel containing the fuel-air mixture. As the piston is pushed to the right, the volume is reduced and the fuel-air mixture is compressed during the compression stroke. During the compression, no heat is transferred to the fuel-air mixture. As the volume is decreased because of the piston's motion, the pressure in the gas is increased. As described by the laws of thermodynamics in the figure, the mixture has been colored yellow to denote a moderate increase in pressure. To produce increased pressure, we have to do work on the mixture. During the compression stroke, the electrical contact is kept open. When the volume is the smallest and the pressure the highest as shown in the figure, the contact is closed and a current of electricity flows through the plug. Next comes the power stroke. At the beginning of the power stroke, the electrical contact is open. The sudden opening of the contact produces a spark in the combustion chamber which ignites the fuel-air mixture. Rapid combustion of the fuel releases heat and produces exhaust gases in the combustion chamber. Because the intake and exhaust valves are closed, the combustion of the fuel takes place in totally enclosed vessel. The combustion increases the temperature of the exhaust gases, any residual air in the combustion chamber, and the combustion chamber itself. From the ideal gas law, the increased temperature of the gases also produces an increased pressure in the combustion chamber. This is colored in red to denote high pressure. The high pressure of the gases acting on the face of the piston cause the piston to move to the left, which initiates the power stroke. Unlike the compression stroke, the hot gas does work on the piston during the power stroke. The force on the piston is transmitted by the piston rod to the crankshaft, where the linear motion of the piston is converted to angular motion of the crankshaft. The work done on the piston is then used to turn the shaft and the propellers and to compress the gases in the neighboring cylinder's compression stroke. Having produced the igniting spark, the electrical contact remains open. During the power stroke, the volume occupied by the gases is increased because of the piston motion, and no heat is transferred to the fuel-air mixture. As the volume is increased because of the piston motion, the pressure and temperature of the gases are decreased. The exhaust molecules are colored yellow to denote a moderate amount of pressure at the end of the power stroke. At the end of the power stroke, the piston is located at the far left. Heat that is left over from the power stroke is now transferred to the water in the water jacket until the pressure approaches atmospheric pressure. The exhaust valve is then opened by the cam, pushing on the rocker arm to begin the exhaust stroke. The purpose of the exhaust stroke is to clear the cylinder of the spent exhaust in preparation for another ignition cycle. As the exhaust stroke begins, the cylinder and combustion chamber are full of exhaust products at lower pressure, colored blue in the figure. Because the exhaust valve is open, the exhaust gas is pushed past the valve and exits the engine. The intake valve is closed and the electrical contact is open during the movement of the piston. At the end of the exhaust stroke, the exhaust valve is closed and the engine begins another intake stroke.